This is the Blue M convection oven model DCC-256. It has a temperature range of 15 degrees above ambient up to 250 degrees C. The Blue Oven oven is controlled by the Pro 750 controller. This controller controls the heating, purge, and cooling functions of the oven. In addition, the controller also controls the alarm systems. The alarm systems consists of a nitrogen alarm, which monitors the nitrogen level to the chamber, and a trace oxygen monitor, which also monitors the level of oxygen in the chamber. These alarms work, for example, the oven requires 70 psi of dry nitrogen or an inert gas to operate. If that pressure should drop below 70 psi, an alarm will sound, and it will also inhibit the heating of the oven. Once the pressure has been restored, the alarm will return. In addition, there is also an over-temp alarm as well that is inline and basically slave to the controller. If for some reason the temperature should go over the high temp set point, it will sound as well, and until that has been put back, then it'll allow the heaters to come back on. Now let's go take a look at the connections in the back. The oven requires a service of 220 volts, 3-phase, 60 hertz, preferably a 30 amp service. In addition, it requires a house water supply of normally between 3 to 4 gallons per minute at suggested to be below 70 degrees C. The colder the water, the quicker the oven will cool when in operation. This is important. This is the return for the water. But when this comes out of the oven, initially there's a cooling coil inside. So when it comes out, it absolutely must go to a floor drain, because it will emit a small blast of steam initially when it starts its cooling cycle. Then it'll just be hot water, and eventually it'll go cool. The only other connection required is of course, the nitrogen line that I discussed earlier. Again, that should be a minimum of 70 and a maximum of 90 psi. Performance of the oven has been logged, and this information is always sent to the customer. It proves that the oven has the capability to heat up, soak, or maintain a temperature and cool down within a reasonable amount of time. Earlier we spoke about the oxygen monitor. Presently, the Series 3510 trace oxygen transmitter, as they call it, which is normally attached to this oven, has been sent to the manufacturer, Alpha Omega, for complete overhaul. It will include a new sensor along with a accurate, up-to-date calibration. This is a very important piece to this oven, because this is absolutely not supposed to ever be used for any kind of toxicity or combustible type of material. To simulate the operation of this, we have hooked up a power supply that simulates the signal that normally this would send to the oven to, for example, turn off the heat or the other functions in the event there was a surge or a trace level of oxygen. Now, for example, I'll step over here so you folks can see this. The oxygen monitor has a range of 0 to 10,000 parts per million. So, if, for example, the monitor was to sense that it was more than 10,000, it would light the alarm, or the indicator light, it would sound the alarm, and it would shut down the heating operation of the oven. To simulate this, I will raise the oxygen level, for example, up to about 7,200. I can raise it a little bit more to just below 10,000. And of course, if it goes over 10,000, it will immediately shut the heat down, open up the purge valves to fill the chamber under pressure with nitrogen, and eventually it should be able to bring that oxygen level back down below the customer's set point, which in this case is 10,000 parts per million. The actual operation of it is very, very simple. Once it is programmed, it's basically main breaker on, power on, the controller boots up in a very short amount of time. And you can run your program, stop your programs from here. And it's actually a very simple piece of equipment to use.